Now we are discussing how to find the address of a variable. In C language, we used the ampersand to find the address of a particular variable. So I am giving a is equal to 2. I want to know what is this address of variable a. For that, in the Python, we have id. So id of a gives the address of a. Address of a is some big number. Last three digits are 536. Now I am changing the value of a to 3. Before changing it, we will assign b also with 2. We expect as usually, because in the C language we know when we declare the two variables, the compiler allocates, the compiler tells to our operating system to allocate, I have two variables a and b, allocate 4 bytes, different bytes to those two variables. So we generally expect the address of b to be different from a, but in Python you observe this, the address of b is same as the address of a. This is a little bit surprising, right? Now we assign some variable c with the same value of 2, or I will assign the value of a to the c assignment statement. Now I am checking what is this address of c. So the address of a and address of b and address of c all are same. What is happening? How three variables can reside in the same memory location? Actually, the three variables are not residing in the same memory location, but the three variables are tagging to the same data. They are indicating the same data. This is the two. That is what we are calling as an object. So here, the memory location, here the address that is indicating 536. I have, for the convenience, I have taken the last three letters. So when we assigned a with the 2, so here it is, this a is mapping to this 2 or tagging to the 2, and b is also tagging, b is tagging towards 2, and c is also mapping towards this 2. So even though we give 100 variables, if we give the value of 2 to the 100 variables, those 100 variables can use the same memory location. That's why Python is the most memory efficient language. That's why we are using the Python in the deep learning where and machine learning, where we have to handle the data, that is huge data we have to handle. Then Python is one of the memory efficient language. Now we are checking, what if I am changing the value of a to 3. If our concept is correct, because the address is allocated to data, now I have changed the value of a to 3. Now the address of a should change. Now we will check whether in the real time that is happening or not. Now the address of a is changed to 568. What it means? So again there is a address to the variable a. The variable a is tagging to the 3, data 3, which is allocated with the address 568. Now a is tagging to 3, but a is not tagging to towards the 2. Okay, I will also tag b to the 3. Now I am changing b to the 3. So address of b also, now same 568, absolutely. Now I am also tagging c to 3. Now address of c also changes to 568. Now what happens to this 2? No variable is tagging. Okay, what happens to 2? We will check. Now because no variable is tagging towards this 2, I am giving the new variable d is equal to 2. We will check what is the address of d. Still we are getting the same address. That means this 2 is residing in the address location. This is the clear indication. Even though we have started with assigning a variable a, integer variable a with the 2, after that we have changed the value of a to the 3. So the address of a is changed to 568, and b is changed to 568, and c is changed to 568. Now no variable is mapping, or no variable is tagged to the address. Still when I give the new variable d, still when I assign the new variable d is equal to 2, that D is tagging to the same address 536. Now if we check what is the address of the 2, the address of 2 is 536. If we check what is the address of 3, the address of 3 is 568. So this is how in the Python, whenever we are assigning the data to a variable, in the real time, the variable is tagging to the data. If we use the hundreds of variables with the same data, then those hundreds of variables can use the same memory location. Now we work with the string data type. This time I am giving some C is equal to GPT. Now I am asking what is the address of C. Some address is coming 192. Now I am giving D is equal to C, same data I am assigning to D. Now I am checking what is the address of D. Address of D is also 192. Now I am asking what is the address of GPT. The address of GPT is also 192. I have changed the C to some AMDV. Okay. Now the address of C is changed to new value. Now I have changed the D also. So address of D is also 96. Now we are taking some floating value. A is equal to 10.5. We are checking the address of this floating value. ID of A, the address of this is 792. Now we are assigning this A to B. Now we are expecting the same address to the B also. The address of B is also 792. Now we are assigning the value in A to C. We are expecting same address for C also, because here A and B and C are tagging to the same value 10.5. We are getting the same address. You may give hundreds of values, and you may take hundreds of variables, and if you assign every variable with the A, I am taking another variable Z, I am assigning the Z with A. If I check the address of Z, again the address of Z will be same, 792. This is how we will check the address of a variable in Python. And also from here we have confirmed that whenever we are checking the address, we are actually checking the not the real address of the variable, we are checking the address of the data. That thing we have confirmed here.